Recording in progress.
Welcome, everybody. We're going to be working on the Unit 4 exercises today for our MySQL class. And brand new command for us here, and we talked about it briefly during the lecture. And we're going to play with some commands that are potentially destructive here today. And the main focus, remember, is to learn about insert, update, and delete. Insert is simply adding records to a database table. Update alters records, and then delete destroys records. And whenever you're altering or deleting records, you do run the risk of damaging your database. So you often have to proceed very cautiously. And I'm noticing here I have answers pasted in, which I shouldn't. So I'm going to delete this out of here because we're going to build that from scratch. So sorry about that. So you guys got the answers to the first one right off the bat. But the point is that when we're doing this type of work, especially when you're first learning how to do it, it's not a bad idea to create a blank database, build some tables, and then basically have something that you can safely tinker with without worrying about destroying the real thing, right? So, and database programmers do this type of thing. Sometimes they do it within the same database. They'll create like a duplicate of a table just to test out their code. And then when they're ready to launch it, they'll apply it to the real actual database that they're working on. But if we need kind of, let's call it a sandbox environment to build a database safely to potentially destroy things, let's create one from scratch, and you can see the command there. And what they want us to do is create one called create database, my database. And if you want, and it's perfectly viable, you can actually copy that command from here and just bring it over to MySQL Workbench. Now, in the background, of course, MySQL Server should be running for you guys. I think I've demonstrated that enough this semester. And then log into your MySQL server through MySQL Workbench, and let's create a new query window here. So I'm just clicking that first icon there to create a new SQL code window. I am going to zoom in on it a little bit, and I'm going to paste in my code. And we're just going to call this my database. Okay. So keywords are create database, my database. It really is just that easy to create an empty structure. Once you have that pasted in or typed in, just go ahead and hit the execute command, and it says, can't create it. Why can't I create it? And this is where, we kind of walk into this blindly because I forgot that I have already created it. And you know what? Since we're playing with this stuff, I can also drop a database if you're wondering how you destroy one. And I'm going to say this with extreme caution. Don't do this with a production database because, yeah, you would get rid of the whole thing, even if it had millions of records. Right, so I'm going to go ahead and execute this command. All right, so that worked. So now up here, I can go back to my original command, right, and create my database. So let's do that. And then after you do that, make sure you hit the little refresh thing in the schema so that you can see it appear over here. Now, for right now, if we start writing SQL code, the code won't attach to that file until we do a use statement. So I'm going to say use my database, semicolon, and we'll execute that command. And now every subsequent command, of course, will attach to that database. So don't forget those use statements as you kind of move forward. All right, let's go back to the instruction document here and look at our directive for number 2. So number 2 says create a new table named student, and it should have the following fields. And notice when we put this assignment together, we put a little bit of thought as to like what should go into each column, right? And folks, if you were designing a database, and I know like in the lecture I used the example like that maybe you have a record collection or collection of music or whatever, and you wanted to build a database to store it, before you just like start like pumping out column names and whatever, you might want to think about what you're going to build first. And database people do this. And this is a table, right? It looks like a spreadsheet, but very often that's what database people do is they'll make a little spreadsheet, go, which columns do we need? What's the data type going to be? Can it be null? What's the purpose of it? What's the description? And then that helps to decide the other pieces of information. They don't just like go in there and willy-nilly type stuff in, you know. And if you can imagine, if there's more than one table you need in a database, it might actually be like a process like we do for like regular coding where we pseudocode like what we're going to code before we code it. We do the same thing in a database, and okay, given the fact that this is kind of a sample database to play with commands, it's not really super important. But if we were building a production database, we would really want to sit down and think about what columns we're building and why we're building them and what they would contain and what might be the limitations of the stuff that we're typing in. Now, there's a very, very clear listing here of the approach, right? And if you followed along with the lecture materials, and yeah, you can jump back to that, or you can look at the W3 site for examples if you don't remember how to do it. This is not exactly in database format here, but it's close, right? And it helps you write the code. That's kind of the point. So let's go back over to MySQL Workbench, and if it's helpful for you, and I'm just going to give you guys a tip. If you're multi-screening, take this document and put it on the other screen, and then in the main screen, you can look at MySQL Workbench, and then you just go back and forth. Another approach I sometimes do is I don't want to look at the whole document, so I just pull out my snipping tool, and I just grab the part that I need, and then I can take that window and move it over to the other screen. And I apologize for the video, but the top bar of my snipping tool is on the other screen, which is behind the screen, so I couldn't see it. So yeah, weird video interlude there. But now I'm looking at that on my other screen. If you guys are not multi-screeners, by the way, you might want to start considering becoming one. We were up north this weekend, and we stopped at, I forget if it was a St. Vinny's or a Goodwill, and they had an excellent collection of old monitors. And I was like, oh, yeah, they're only like $10, $15. I'm just putting it out there. You're gonna have to drop hundreds to get a second screen. All right, so let's go back to MySQL Workbench and start coding this. When we create a table, of course, we use the create command, and we use the keyword table. That's what we're building, after all. And they want us to call this table. Did they tell us what they want us to call it? Student, right? So I'm going to call it student. And then here's my habit when I do this, right? Because I know from the syntax of this, I'm going to have to put all the stuff I'm going to do inside of a pair of parentheses. And at the end of it, I need a semicolon. So I just type that in first. Right. Then I put my cursor in between the parentheses, and I press enter a couple of times. And I do that. Now, here's the why I do this, by the way. This product, even though it's a great product, doesn't do autocomplete. Like if you're used to coding in other languages, your IDE sometimes like autocompletes phrases for you, right? And it's yeah, it's wonderful. Let's just go with it. But here, if you forget to do it and you're like, my code's not working, I don't know why. If you open and close the parentheses and put the semicolon in first, it really eliminates that from happening. Old school habit, I know, but you know what? That's how it goes sometimes. All right, what I'm going to do now is I'm going to go to the first blank line within here, and I'm going to press the tab key to come in from the margin, because that way I can see all the columns I'm going to create. And we have a listing, which is on my other screen right now, right? Just to kind of refresh, here it is. I can grab it, right? So we're trying to build that. So I'm going to build the first column, which is called student ID. And the way they named it was a capital S and a capital ID, right? Then we need to declare that it's an integer. And here's a tip, by the way. I'm going to put tab stops after all the column names, because when I look at all the fields I'm going to create later, I want them to all line up nicely. Right? Just easier on my eyes. So the data type is going to be integer, meaning ID numbers will be numbers. Then I'm going to press tab again, maybe twice actually. And I'm going to designate this to be my primary key field. And therefore, it cannot be null, cannot be left empty. And unlike what we saw in the lecture, which is what W3 was recommending, I like to put my primary key designation here on the same line. And actually, I want you also to notice I'm going to put another tab stop in there, just spreading them out. Eventually, I'm going to make columns, for each one. All right, since I'm going to declare more columns, I'm going to put a comma here, press enter, and move on to the next thing. And the next column name is student last name. Notice the camel casing. And then this data type is going to be varchar, parentheses, and what we were told to set it for was 25 characters. I'm also going to put a tab stop up here right before the integer thing because I'm noticing my data types aren't going to already not going to line up. And yeah, I'm getting kind of like format picky here already. That's okay. Whatever works for you. You don't have to put the tab stops in there at all. It does. SQL doesn't care. We just do what's comfortable for your eyes. I can just tell you from experience for myself that I like it when everything lines up. It's just so much easier to look at later, especially. So, and there it is. I'm adding another tab stop. This one we're told to make 20 characters long. Another comma. So first name, last name, first name. Now we move on to the student address. This will be a varchar of size 30. Oh, okay. Well, there's a couple of things that we missed. Now I'm looking at my table going, oh, it did tell me that the last name should be not null. I forgot it, right? And that the first name should be not null. In other words, they can't be left empty. The address, interestingly, that can be left empty. Why? Because that's what we were told. Next column would be the student city. Once again, a varchar, size 15. Now, I'm just going to make a little commentary here. I think if I was naming these columns, and I'm just going to be real frank, I wouldn't include the word student in front of every name. I'm not the one who built this assignment, but whatever, that's pretty irrelevant. But there are database administrators that like to do this because if the column name ever comes up in a query, they can identify very quickly which table it came from. So that's kind of a thing. But I would, if I was doing it, I would probably skip that on all of them except for the ID. Just saying. Next thing that we need to put in there is the state. So we'll say student state. And then notice here, instead of using a varchar, we're going to use just a character and we're going to set it to 2. We talked about that earlier, right? Because we can do any state with 2 letters. Right. That's all the columns that we need to create. I'm going to get rid of this extra blank line here, and then I'm going to go ahead and run the query. I do want to just point out a couple of things, though. Commas between each column names and their data types, right? There's commas. The last one doesn't have a comma because it doesn't need it, right? I put tab stops in to organize my columns. I think it's easier to look at than squeezing it all in on one line. Kind of makes it look table-like. Since my cursor's inside the code, I'm going to hit the second lightning bolt here and run it. And notice it did build it. And then over here, if I refresh the schema, you'll notice a little arrow appears by the tables, and there's the student table. And then more importantly, look at your little information window here and notice how the student ID is bolded. and it indicates here that it's a primary key. I do want you to remember that there's the other way of doing the primary key, right? Which is where you list it at the bottom uh, and then put the field that you're attaching it to inside the parentheses for it. I do much more prefer this approach. This is just me. With foreign keys, you can't really quite do it this way. But with primary keys, since they're usually listed at the top, I like this approach. It's pretty basic and it works. So that's the approach I'm generally going to use. All right, so that's your code for exercise number 2. You guys get it all to work? Okay. Let's take a really quick pause here. Point.
Progress.
All right, so we fixed a couple problems that people were having, but then we ran into another problem, and this is me not paying close attention to what I'm doing here. But somebody pointed out that there's more on the next page, and we forgot to do that. So I'll tell you what, this will be a great teaching point because we haven't learned how to remove a table yet. So here's what we're going to do. I'm just going to throw in a command here really quick. We're going to drop the table, and folks, normally this is not how I would fix it. Normally we would do an alter table. We haven't learned that command yet. So we're going to drop the table student for right now. This is kind of the brute force approach. And this is why we do it like in a temporary database and not a real one. So we executed it. And then we're going to come back here and add the rest of the fields. And by the way, the rest of the fields are the zip, phone, and date of birth. And once again, I'm going to screenshot those, put them on screen number 2 so I can see them. Next time I'll remember to scroll. But hey, it happens, right? But it just shows you if you get into that situation, because some of you are going to walk into that trap, right? Now you know how to take care of it. So you can drop the table, and I can put a little thing here, and I can say, because I forgot some columns. All right, so let's do the rest of them. So we have a student zip. That's going to be a varchar of size 9. Is that adequate? All right, I'm going to argue against it. Yeah, why is the no? There's a dash in the middle, right? And you know what? I'm going to make it size 10 because, okay, first of all, most people don't know the 4-digit extension on your zip code. Do you guys know your 4-digit extension in your zip code? I do, and it's kind of a weird thing. Really strange, unnecessary fact. I have a friend that's worked at the post office since he graduated high school, and he's the guy that takes handwritten letters that don't have the 4-digit extension on it, and he's memorized all the zip codes in the whole country. But every once in a while he looks one up. But yeah, he's done that job for so long that he just knows them all. Yeah, I think that's just like hilarious. Unnecessary information, but that's what happens to humans when they do something for too long. We're also going to do student phone. That's a varchar. We had this discussion too, right? Like how big is big enough? We're going to go with 12, right? That's what we were told. That's what we're going to do, right? Why 12? 10 numbers and then 2 dashes. I could argue 13 or more, but whatever. And then we have the student date of birth. So student DOB. And what format should that be? Here's the first weird one. Well, this is going to be a date, not data, date. And this one cannot be null. So we need a date of birth on this. All right, now we can run our create table command again. So let's do that. First time was just practice. All right, then over here in the schema table, we'll refresh. We'll click on the table. And then notice with the new columns, all the data types listed of the appropriate sizes, the primary key is indicated, and we have our first table, folks. All right, let's move on to the next one. And you guys should be taking your code and copy pasting it into these green boxes at this point. All right, create a new table named department. Once again, I'm gonna screenshot that just so I have it on my other screen here. It's gonna have a department ID and a department name. We've got an integer and a varchar, a primary key, two not nulls, and a little explanation of what the table is used for. So let's do that. It should be pretty easy compared to the one we just did, right? Create table, we'll call it department, open and close parentheses, and a semicolon, cursor between the parentheses, press enter a couple of times. Pressing the tab key here, we will have a department ID. It will be an int, not null. Notice I'm using like the column spacing from above, and then primary key, comma, and then we'll have the department name. That's going to be a varchar size 30. That's not null. And that's it, folks. That's all we have in that table. Go ahead and run that snippet. Refresh your schema and notice the table is now there. Of course, if you run the query to see the information inside the table, they're both empty, right? There's nothing in them yet. We just built the framework for it, not the data. All right. Next one is create a table named instructor. This time I'm smart enough to scroll to the second page. All right, so if you want to screenshot that or whatever, move the document over to the other screen. But we'll have an ID, first, last name, phone, and a department ID. And I think that's it. Yep, that's it. So we will create table instructor, open and close parens, semicolon, split that, click in between, tab in once, and now start building your columns. So we have instructor ID, so int again, not as, will be not null, and it will be our primary key. Then we'll do instructor last name. Settings are probably similar. I don't know why we're giving the instructors longer last names, maybe because they have titles. All the different letters that they've earned. That's going to be not null. And then we'll do their first name. And that'll be of size 20. And also not null. Then we'll get their phone number in there. And I would say email is probably more important now, but whatever. And we'll follow the same approach we used above. We'll just do a varchar 12. And then we'll have instructor, department, ID, space in there. And then that's going to be an int, and that cannot be null. You notice my columns are kind of falling apart here a little bit. If it really troubles your eyes, you can just tab all those over and get them to line up. Whatever works for you. I mean, really is what it comes down to. that helps you to look at it like this, then do that. Now, the other important aspect here is that in order to link them to a department, I need to take the department ID from the department table, which is a primary key, and make it a foreign key in this table. So here comes the syntax. I'm going to say foreign key. Then I'm going to list the field from this table that's going to contain it, which is going to be the instructor department ID, and then what it references. So we'll use the keyword references. And what's it referencing? Well, we have to look at the department table. So we'll just say department. Where did my cursor go? There it is. I must have hit the touchpad here. And then inside parentheses, the primary key field from that table that we're pulling in. So it's not the primary key for this table, it's the primary key for a different table. And in this table, it becomes a foreign key. And it ensures that we're not assigning a faculty member to a department that doesn't exist. See the logic? All right, let's go ahead and run that code. Once again, I would have you refresh the schema table, click on the table, and then look at the links. The one I want you to notice here is, notice how the primary key up at the top here is bolded and underlined, showing it's a primary key. And then this one is bolded, showing it's a foreign key. Right? And some database systems will put a little FK next to it, whatever, but that's the indicator here in MySQL Workbench. Right, so now we have 3 tables to work with. Now we need information, right? So if you go over to the instructions, what they're doing is they're giving us a listing of information they want you to enter into the table. And remember, the command that we use to do that is insert into, right? And it said right at the beginning of number 5 there, what the command is. Now, I'm going to pause the video here for just a moment.
Recording in progress.
All right, so we're going to work on this insert into command. So I'm going to go back over to MySQL Workbench and start doing that. And once again, I'm going to capture this information and look at it on my other screen. All right, so let's go down here and type our insert into. And for the first one, we're inserting into the department table. What are we inserting? So set of parentheses here. We're going to try to populate both columns. Why? Because neither one can be null. I can see the table definition above, right? Neither can be null. So what are those field names? It's department ID and department, let's spell it right, in that order. Then we will add the following values. Once again, between parentheses, I'm putting my semicolon in so I don't forget, but the information that goes here must be in the order of the columns listed on line 33. So the department ID, well, this is the first one, so let's just give it an ID of 1. It's an integer, right? So I can just type a number. And then the department name in this case would be Business Information Tech, right? I'm going to use single quotes for this. You could use double quotes too. And then we'll close the quotes. Now, that's the first entry. So if I just ran this, that would go into the database, but I want to add multiple records all at once. So here's the format that a lot of people use. So once again, I would put my cursor at the end of this line here and then press enter, and I'll do that a couple of times. And then what I'll do is I'll put in other sets of parentheses, but if I'm putting in multiple values, multiple entries, I can put commas in between, right? Once again, I'm going to tab over, and yeah, I like to have stuff lined up. I'm going to tab over and I'll put in my second entry, which would be 2. And then this one is marketing, comma. Next one, 3. This one's going to be accounting. Close paren, comma. Number 4 is electronics. And the last one, number 5, is industrial. So no comma needed after the last one. We just need that semicolon. And I don't know if you saw what I just did, but I moved it up to the end of the line. These could be all strung out on one string. I think it's easier to look at this way because then you can see each one. It's kind of like a table row, right? And then when you have more than one column, it all kind of lines up and you can see the records that are going in. Go ahead and run the command. Make sure the code gets in there. It looks like it worked. So this was going into the department table. So now I'm going to come up to the department table here and check to see if the stuff is in there. I could use the little icon here, right? Or I could manually write the query, which is basically select all from that table. And then you'll see that indeed the stuff made it to the table. And I would say when you're screenshotting this, I would appreciate to see this output so that I can make sure the data got in there. So back to the query that created it, and then verifying that it actually works. All right, let's move on to the next one. With any luck, we should be able to finish this here today, which would be very nice. Actually, before I go to the next one, I just want to throw another thought out there to you. When you're inserting these records in there, you don't have to do them all in one fell swoop, right? Let's say somebody says, well, I think we need a new department. All right, well, let's run that command again. In fact, I can borrow this command, right? Let's paste it, and then I can do values again. And then I'm going to come up with a department number 6, and we'll call it AI. How about that? Or maybe for you AI data people, AI data, semicolon, and I can run that command. And then if I come back here and run this query again, you can see that it was added. Right, so it doesn't all have to happen at once. That's kind of the grand point. You do one record at a time if you wish, right? If you have all the information, you can do a bunch of them at once, do it. If not, one record at a time works just as well. Next exercise. Now we need to add the instructors. And here's where you guys might want to hop into the Zoom that's running and not have to type all this because there's like phone numbers and stuff. Yeah. The other thing I will say is I don't care if the phone numbers are exact, but I would like the rest of the information to be exact as is in the image. All right, so here I go. I'm going to start by, well, I guess I should look at that really closely because there's a lot more columns here, right? There's ID, last, first, phone, and department. So the values are, it's going to be a longer list of values and a longer list of columns this time. Back to the main SQL document here, we're going to add a couple of blank lines and we'll say insert into instructor the following column names, right? So we have to copy those column names. So that's going to be instructor ID, instructor last name, instructor, first name, instructor phone, and then instructor department, if I can spell it right, ID, which is the foreign key from the other table. Are you guys noticing how long that line's getting? And yeah, I am zoomed in on my code, so that might not be happening to you, but it's perfectly acceptable, by the way. If you want to put your cursor in here and split that up, and like what I would do is I'd lay it out like that, right? So it doesn't scroll off the edge of the screen. Once again, SQL doesn't care like how the code's formatted on the screen. That's for our benefit, not for its benefit. So I would do this. And then I would begin typing my values. Once again, they have to be going in the order that they're provided. And so, for example, here is my first entry. And then, yeah, that's copied exactly from that table, right? And what I will say for those of you here in the session that were smart enough to jump in the Zoom, yeah, I'm not going to type them all because we're going to be here forever. Here's the rest of it. And one of the advantages of being in person, folks, during the live class session, the rest of it is in the chat window in Zoom. If you're not logged into Zoom yet, and you log in, that won't be there. By the way, I'll have to repaste it. But if you do, you can grab it right from there. I'm just trying to save you some typing. But otherwise, what I would ask is that you manually go through and type that all in. Ideally, with everything being precise. This is a really goofy little thing. And let me run this code to make sure that it works. Looks like it worked. How can I verify? I refresh my schema table. I'm going to go to the instructor table. I'm going to view the contents. Oh, and it's blank. So did it work? I must not have run it correctly. Let's try that again. Did I forget something? All right. I think my format's okay. I didn't get an error message. Maybe I didn't fully hit the lightning bolt. Here's the run. Okay, it looks like it worked this time. So now I'm going to go to the instructor table and look. Yep, and there's all the data. Yes, here it is. Right, and fortunately, it's not like 100 entries. Right, but the thing that I was going to mention, and this is like one of those, you know, back in my day kind of things, basically, like one of my first jobs out of school is I worked for a publishing company as a temp. And what they did is they took me and they put me on database entry, right? Where I would take all the letters that would come into the place and basically take the content of the letters and all the details and create a database out of it so they could just look at it on the computer screens and not have to read the letters, if you feel what I'm saying. But that was like all manual entry, right? I had to type in all of it and make sure it was as precise as possible. Of course, they have tech now that can kind of supersede that. But, you know, getting information into a database, we call that data entry. That used to be a job, like with job titles. Right? Not that that's not around anymore, but a lot of that stuff is handled in other ways now. Like, how many times do you fill out a form on paper these days? Not very often. Right? So if you got it to work, you should have data inside the instructor table. And then we have a couple more things to do here. We have 9 minutes left. So the next one, by the way, and if you guys are in the chat, or in the Zoom session, once again, I'm going to be putting a lot more code in there just to accelerate our workflow here because we are running out of time and I would rather not do this next week. So what I'm going to do is the next one is to basically insert a bunch of student information. So with the student information, here's the first part of the query coming in the chat right now. And that is to insert into the student table. Notice all the columns of the student table, and this one's got a lot, right? In fact, I missed some of them the first time around. But ID, name, address, city, state, zip, phone, and date of birth. And then, of course, we will start to insert values. So here's the first one. And I'm going to go to the margin here. You can see how wide that is. That's because I'm tabbed over. I probably shouldn't be. It still doesn't quite fit, so I'll zoom out a little bit just so you can see it. And then if you do the due diligence of reading through that table and mechanically typing this all, here's the rest of it. And so all the values right now are ending up in the chat. I think I just saved you about a half hour of time. Right. Now, the truth be told, it doesn't really matter. Like if you don't type in exactly the right value and it's a little bit off, right? As long as the data types work. But if you were doing this professionally, you'd have to make sure every entry was absolutely correct. Once you have that all in there, go ahead and execute. And then once again, what I would suggest is that you look inside the table to make sure the data actually got there. And it did. Okay, so now we have a few additional exercises here where we're gonna run a query to pull some information. Now that we have information in there, we're gonna update one record and then we're gonna delete two. Okay, so I'm gonna do this kind of in hurry up mode because we have 7 minutes, so I might spill a little bit over class. I'm not gonna bounce back and forth to the exercise document. I'm just gonna plow through and write the queries because I have them here on my cheat sheet. So you'll have to match these up with the exercise numbers. So the first directive is to find all the students in the student table and output them ordered by student last name, which is a common query. So let's just build that one from scratch. It's pretty easy. Coming back to the margin here. So we're going to select. This is, the nice part about once you have data in your database, you can actually do stuff with it. We're going to select student ID, student last name, and student first name from the student table. And then we're not filtering it at all. We're just going to order by. And we said student last name. Go ahead and run that. And I know I'm moving quick, but just remember, it will be in the video if I'm going too fast right now. You can always rewind and take a look. Right. Notice it's not pulling back all the columns we don't want. We're just pulling back the columns we want to look at. We just want IDs, last and first name, ordered by last name. Did it work? It absolutely did. Okay, next query. Now we're asked to update the phone number for the student who's got the ID number of 123. And they might list that person by name, right? So you might have to look them up otherwise. But we're going to update the student table. And we're going to set the student phone number. And remember, the phone numbers are stored as characters, not as numbers. And we're going to type in whatever the new number is. And this is what I typed last time, so I assume this is sort of correct. Whatever, it doesn't matter what the number changes to as long as you change it. And where the student ID equals a particular student, which is student 123. If I didn't include the where clause, I want you to remember this, all the students would have the same phone number. the where clause ensures that I'm filtering on one student, right? And really, if you were writing this as code or an exercise or an application, you might first run some code to see if the student's even in there, right, and exists. Look at what their current phone number is, update it, and then look at it again to make sure it changed, right? You feel all the steps I'm talking about? We're just writing the query to change it. So if I want to make sure that it changed, maybe the easiest way is just to do this little button here, and then I can look at the student 1, 2, 3, which happens to be the first one, and there's the new phone number. Moving on to the next one. This next one is where we do a delete, and I'm just going to give you guys a heads up here that I have a little notification in the course shell right down here at the bottom that talks about safe mode in MySQL Workbench. So if you run the delete commands, MySQL Workbench has a little tool inside of it that if you forget to put in a where clause on a delete or an update, that it blocks you from doing it. You can override that, right? It's there for safety, obviously. So there might be situations where you might need to switch that on and off. But if you turn it off, right, you have to remember to turn it back on. It's on you. It tells you where to go and how to do it. It's not really a big deal. And once again, we're working with a sample database on purpose. So this one, we are going to delete from the student table where the student ID equals a very specific number, which is 135. And right now we still have an output from the student thing over here. So we can come over here and look at it before and see that's Adams George that we'll be deleting. So let's go ahead and run that query. Here comes the run. And then we can look at the student table again, and sure enough, George is gone. Right, student 135 is no longer in that table. There is no undo, folks. That record is gone forever. Let's do one more. This one asks us to delete a department. So we're going to go delete from the department table where the department ID equals, and I think they're asking us to do department number 4. And once again, I'm going to look at the information before. We're deleting electronics, right? So when I check it later, so let's go ahead and run that. And now let's look at the data inside there. Did I not do that correctly? Where department ID equals 4. I think I did it correctly. Oh, error. Cannot delete or update a parent row. A foreign key constraint fails. And now the question is, and I think there's a question on the document, why can't you do this? And I want you to think about this. And that goes back to the building of these tables. And it's not a bad idea to look at the create table commands, right? So the department ID is a primary key here. So in principle, I could just delete it. Okay, no problem. But in the instructor table, right? So if I go to the instructor table and look at the data, apparently I have Butch Brown is an instructor in that department, as is Sue Williams. So I can't delete that record until I switch them to a different department. You guys see how a foreign key kind of enforces database information? I can't just go blowing away the department and all of a sudden these people don't have jobs. And because it's a foreign key in a different table, it's not going to work. It's kind of interesting, right? So what I could do is I could run update queries to change them to a different department. Maybe I could move them over to AI data, if that makes sense. And then I could do the delete and it would work because nobody's in that department. That's kind of the thing. That's a mechanical aspect of foreign key and primary keys, but that's how they work to kind of make sure that data doesn't get screwed up in a database, and why sometimes you can delete data and sometimes you cannot. All right, that completes the exercises for Unit 4, and this video ends here.